Pick me up. So, all right, cool. Let me know when you're ready, Scott. Okay, cool. Thanks. Well, thank you everybody for coming out. Thank you to Improving. I work here at Improving. And thank you for coming tonight. My name is Jim Bethencourt, and I'm your host. And thank you, Scott, for arranging this meeting. Thank you, Pratik, for speaking tonight. Very, very excited. And a little bit about Improving. So we are the we do have user group space available. So if you have an idea for user group, or if you are and you're enthusiastic about it, come talk to me. I'd be happy to help figure out how you can host that user group. We have several already right now. We host Free Code Camp. We host the Houston.net user group. In fact, they're right next door. We have Lean Beers right in the conference room. And we also have a fun one called the Houston Side Project Society that meets once a month. And what else? Houston Product Community. I don't think that they're still meeting, but so they've been coming for a long time. And so if you have an interest, we'd be happy to host you.
There's no AI group though.
So actually, I think there is. We're gonna start hosting their meetings here now. Actually, no, AI Houston, I think is the name of the group. Yeah, yeah. So they were meeting in what looked kind of like they were meeting downtown, but in kind of an unfinished space, if I could put it that way. So they're meeting now here. And so we're also looking to hire senior .NET developers, Java developers, and senior DevOps engineers, as well as Agile coaches. And we are currently looking for a sales executive. If you know someone who is a seasoned sales executive of software sales, we'd be happy to talk to you. And also we have these specific positions that we're hiring for Databricks and Angular.NET developers and platform engineers, and as I mentioned, sales executives. And also, we are the largest provider of Scrum training in North America. So if you'd like to get your Scrum certification, we have all the way from Agile's professional Scrum Master 1 through 3 and Professional Scrum Product Owner 1 through 3. And several other offerings now. How to apply Agile in AI on AI teams, which is quite handy, quite nice to know. And Agile Professional Scrum for developers as well, if that's something that you're interested in. And again, you can go to improving.com/training to find our full schedule. We have primarily online offerings now. It's worked out really well for us, and it's easy to deliver. And we have both 2- and 3-day training offerings as well. 3-day training offerings are great because they don't eat up your entire workday, and there's still plenty of time to actually learn a lot. And then if you could please take a moment and pull out your phone and sign in here, I would really appreciate it. This helps keep the Houston Java user group going, so that way we know that it's worth hosting, basically. So your sign in would be immensely helpful. And thank you so much. All right. Everybody got it? I see one more. 2 more. Okay, great. Thank you so much. Really, really appreciate it. Definitely helps keep these meetings going. And then also, last but certainly not least, we have the door prize QR code. So don't put your phones away just yet. This is how you can win a prize. We have what is this got? Is it JetBrains?
Yeah, JetBrains license to any JetBrains product for a year. Tomorrow the
Sonargraph.
Yes. And the Webucator license, which is one training product that they have.
Awesome. That's great. Cool. Well, I think that's about it. Anybody else need the door prize link? I see a couple there. Yep. Okay, good. Good. And then also definitely want to mention here that we have a meeting on Saturday, October 18th. Scott has sent out the invites for that. If you want to learn about it and find out more about it, where's the best place you can go to RSVP for that?
Well, Eventbrite. You can find it on our LinkedIn. It's also the link to it should be. You can get to our Eventbrite page from the HJUG site, which is hjug.org, and or you can talk to me.
Okay, great. Fantastic. Thank you so much, Scott. All right. Anything else I can think of? Any big Java news? Java 25 came out?
Yeah.
Yay. All right, cool. I had an opportunity. It's very exciting. At the client where I am, we had an innovation week, and I took the opportunity to get to have Java communicate with my GPU on my laptop. So that was a lot of fun. Very cool, using the foreign function and memory interface. So that was a lot of fun. And the compressed object headers saved about 10% of heap space too. Pretty cool. So if you're in a memory constrained environment like I am and my client, that can make a lot of difference. So all right, I think that's about it for me. Thank you all so much, and thank you, Pratik. Thank you, Joe.
Okay, let's share, share. Toolbar over to the side. Should be good. All right, good evening, everybody. Thank you for coming out to the meetup. We have a nice sized crowd here. This is actually my first time speaking at Houston Jug. And yeah, and last night I was in Dallas, actually. So for the Dallas Jug, which was a lot of fun. Where I put my drink? There it is. Yeah, happy to be here. First time. Yeah, I know, right? Well, also, break out my Texas accent down in Atlanta. So, so my name is Pratik Patel. I'm a Java champion based out of Atlanta. I help organize the Java user group there. Also, we run a community conference based out of the Jug in March, early March of 2026. Well, we do it every year, but it's in March of 2026. And you may have written one of the books I've written over the years. And I lead the developer relations team at Azul Systems. And Azul is a company that is a Java only company. We make JVMs and other great things for the Java virtual machine. For example, we have our high performance Java virtual machine and some goodies with it called Azul Platform Prime. And with our customers, we see they drop it in, they get 20, 30, 40% performance gains just by swapping out OpenJDK for our high performance VM. And it works great for big data infrastructure like Apache Kafka because unsurprisingly, big data infrastructure, almost all the software is written in Java because Java is super fast and very stable and has great backwards compatibility and everything else that the folks in this room are probably already familiar with. Okay. And we have this new tool that we came out with about a year or so ago called Code Inventory. And what it does is it plugs into your running application and it allows you to see what you are running in production and what you are not running in production. And we have several customers who have been using it. There's a company that you may have heard of called Netflix. Has anyone heard of these people before? Okay, yeah. So, you know, Netflix has a great engineering team. In fact, we're going to talk about Apache Iceberg a little bit here. And Iceberg came out of Netflix. And there's a whole bunch of big data tools and platforms which have come out of Netflix. Anyways, my point is that they are great. They're one of our customers. They've been trying it, and other folks have tried it. And what all these customers see is that, you know, everyone thinks that, oh, we're maybe not using 5 or 8% of our code. Then they actually go run it in production, and they see that they're not using 30, 40, 50% plus of their code. And what do you do with code that you're not running in production? You delete the crap out of it, to be specific, all right? And the reason why you do that is you reduce maintenance time, reduce technical debt, you reduce risk, and you get all that capacity back to go and do other fun stuff like build out brand new AI and Java projects, right? So, yes, sir.
No, actually, I answered the question myself. It was a dumb question.
Okay, that's okay. It's okay. Yeah. Oh, yeah. What happens over time is, as you are working on a project, and, when you start with the greenfield project, you're probably running everything. Most of that code is being executed and actually used in production. Okay. But what happens over time as you add more features and you refactor and you change things, you basically get what's called technical debt. You basically are using a lot of code that is actually not being used on a production. Right? And this is a big problem because that code is there. And if you don't know if it's being used or not, you err on the side of caution. So what you do is when you change JDK versions, let's say from 8 to 11, you have to go and refactor your code to make it JDK or basically Java 11 plus compliant, right? That was the big leap that we made. How long ago did that come out? Like 8 years ago? Is that right, Scott? When did the JDK 11 come out? Yeah, it was before the pandemic. Yeah. But anyways, it came out a long time ago. But even like for new things, like when you Spring 4 is coming out within the next 6 months. So if you're running Spring 3 right now, you probably want to upgrade at some point. And if you have a bunch of old code that you're not running, you're going to upgrade all this code. You have to do all this manually. It's very tedious, right? It's basically code maintenance. And doing that takes a lot of resources. And I don't know about you, but I don't like maintaining code. I like writing code, right? So what this will do, this tool will allow you to see what you're actually not running and using some I heard some people talking about open rewrite out in the hallway. We have a recipe for open rewrite that will plug into, well, you take the output of our code inventory tool, you plug it into Open Rewrite, and it will do a safe staged removal of that code for you automatically. Okay, so we integrate with that. We work with the Modern people for that tool to work. So yeah, anyways, this is one of the great products we've released in the last year to 18 months. And a lot of people are surprised at how much code they're not running in production. It's actually quite fascinating to see their reaction.
Maximize work time.
Yes, yes. And we have a specific phrase for it that we picked up at the Modern Conference Code Remix by one of the keynote speakers. He specifically referred to it as capacity recovery. So, developers, right? So developers work 40 hours a week, let's say nominally, right? And if you spend 5 or 10 of those hours maintaining code that you're not running, that's 5 or 10 hours you could be working on new features or working on a brand new AI project like we're going to do today. So anyways, and I have a bunch of other presentations. I specialize in performance testing mostly because obviously Azul has a high performance VM and other JVM fun stuff. But this specific presentation, I also have as a hands-on workshop. So if your company is interested in doing a Spring AI hands-on workshop, please let me know. That's a free service that we offer. So we will come to your workplace. My colleague Joe, who's in the back, that lives in Austin, he will buy you tacos and I will teach you some Spring AI. Okay, so let me know if you're interested in that. So, or maybe we can convince Jim to let us rent this room and bring in the Java and bring in the Java community locally for an afternoon of some Spring AI fun, right? We'll see. We'll try to work on that. But again, yeah, and
consider things like AI workshops.
yeah, I'm actually working on taking the demo that I'm showing today and converting it to Quarkus for one of our customers. So I can't tell you who that customer is, unfortunately, but it's a very, very, very large airline. Let's put it like that. Okay. So, but they're a big Quarkus shop, and they are interested in they run Quarkus, and so I was like, oh, it won't take me long. It didn't actually. I've done most of the conversion. It didn't take me long to do that. So. No, eventually it'll be open sourced, right? I haven't finished it yet. Otherwise, it will be open sourced, right? All this stuff I'm going to show you today, all the demos and everything, 100% open source. Okay. So let's get into this, but if you guys don't mind, since we have such a small audience, which is kind of nice because sometimes I'm not humble bragging, to be honest with you. Sometimes when I go speak at a meetup, there'll be like 50 or 100 people. Sometimes there'll be like 15 like today. And I like the small crowds because it can be a little bit more interactive rather than just me lecturing, right? So how about we start off like this? Everyone take like 10 seconds in the room to tell us your name, where you work, and I don't know what your favorite feature of Java is, or if you prefer Kotlin. Oh, I heard somebody talking about Kotlin. If you prefer Kotlin over Java, or if you're still hanging on to Groovy as your primary programming language. Anyways, anything that you would like to tell us. So let's start with you right here, Scott.
I'm Scott Wearshaw, I'm the leader of the HDEV. I do contract work for Shell where I do swing development.
Ooh, swing.
And I like that.
Wait, is NetBeans written in swing? Never mind.
You like my team?
There you go.
Okay, my name is Jason Shagai. I've been out right over 70 years now. I like my profile, I like purpose, I like simplicity brings.
Yeah.
Yeah.
Nice. I used.
I did believe in AI, so
Okay.
when you love.
Nice. Yeah. So I used to work at IBM. I led the IBM Java and Cloud Developer Relations team, and we were when Quarkus first came out. I was there, and so we were one of the first people to like get on board with Quarkus, and I've like tutorials and stuff I've done. Those are quite old now, but anyways.
Slime, work for Ninja One. And actually converted actually a little bit less than 2 years ago.
Nice. So Ninja One makes all stealth products, right? I'm just joking.
Yeah.
That joke didn't land that well. Anyways.
So I work for. I recently would call me. Looks like that's great.
Jim, you already introduced yourself, so we can skip you, I guess. Okay. Yeah.
We'll call you back first.
Oh yeah, that's right.
It's been a lot of fun. Really compiled document, so I'd encourage you to check it out as well yourself. So yeah. Let me know if you have questions.
James Swing, work for Oak Street Health. Oak Street Health is a subsidiary now of CDS. And I think probably my favorite Java feature, which I will buy on the sale, is generics.
Oh, interesting. Okay, I have a whole presentation on why generics are bad. But we'll talk about that. Not bad. They actually, I love generics. They can be difficult to work with sometimes, but so generics are good, obviously, for readability and stuff like that. But the problem with generics is that they have a negative impact on performance, right? So you're probably aware of that fact, but it's a trade-off. Do you write code that's readable or do you write code that's performant? Sometimes you have to find that happy middle ground where you can use generics and you just refactor the code. What's that?
I said, never been accused of writing.
Fair enough. There you go.
Never falls over our body.
That's true. That's true. So, yes, go ahead.
My name is Peter. Pulls back over.
Okay.
I would rather code Python all day, which really goes about Java is Python.
That's right. That's right. It's okay. Python's a nice language, so it's not as fast as Java and stuff like that. But I hate white swear languages, by the way. But that's okay. Go ahead.
Chase as well. Working health. Most of my entire career with Java development. March 2024 is about Databricks, SQL, DBT,
Okay. Nice.
Very careful. Tracking sticks at contract vehicles. Texas. Just because it's super cool.
Mm,
Very.
that's good. So,
the code, right, in TypeScript, I use AI. So it's all working on an app, right? Social media app. So I just want to learn code. So I just, depend on just AI.
Yeah, cool. Welcome. We here in the Java community are very welcoming of junior developers, so you're more than welcome to join. So
I actually have more experience with like in my career time, but my new job, which is job, so I'm trying to.
gotcha. Last but not least.
Sales directors for based out of Austin, Patel region. It's a Texas show with G. And my favorite thing about Java is
There you go. All right, so let's dive into the topics here. We're going to spend, make sure I got the right slide deck up, that helps. We're going to spend most of the time talking about stuff in this diagram, right? So I did have this before, but as I've been iterating on this presentation, I thought it was nice to start with a overall architecture, kind of what is the foundation of like all this AI stuff and how does it relate to the Java world, right? So when we think of the basically how will companies or how do companies build AI applications, right? So there are a number of different ways of looking at this, but so this is a little simplified. But when we think of it at a high level, every company that's going to create a unique AI application, they're going to have some kind of data acquisition and pre-processing as kind of the core foundation of everything that they build or everything that they build their AI apps upon, right? And they'll use big data infrastructure like Kafka. We're going to talk about Iceberg today. They might use Flink. They might even be using Cassandra and other stuff like that, right? And that is primarily for data prep, cleaning, data gathering, data organization, structuring, and all those kinds of things. Okay. Now, the middle part is typically not done in Java. It's mostly done in Python today, which is model building and fine tuning. However, there are libraries like deep learning 4J and something called DeepNets, where you can build models directly in Java if you want. These are typically even in Python, these things are typically used to build models which we call predictive analysis types of models, and not large language models, because large language models require I think the technical word is a crap ton of horsepower to do, right? And when I say crap ton, I mean many millions and millions of dollars. I don't remember what the numbers are for like how much money they spent to build, for example, ChatGPT 4 or 5, but it's well north of like $50 million in compute power, probably 100, maybe more, right? It's a lot. But what companies like the companies that you guys work at, you probably do something called fine tuning or creating a lore for these models. And you can't currently do that in Java, unfortunately. So you have to reach for Python in these cases. But and there's actually a really good tool from the folks over at Red Hat. It's an open source tool called InstructLab, which allows you to also fine tune models. Okay, but you can't fine tune the proprietary models like ChatGPT or Anthropic Claude or whatever, right? Those are all closed source, closed weight models. In this presentation, we'll actually use open source models. We will run them using Olama. I'll explain what all that means in a bit, okay, if you're not familiar with it. But a lot of this stuff nowadays is moving towards something called retrieval augmented generation, or RAG, and also agentic or MCP based server types of things. So this layer right here, where model building and fine tuning has historically been where you go and like kind of do stuff or use RAG, which is kind of hit or miss. It's evolving very quickly. So this layer right here in the middle that it relies on Python is kind of being obsoleted. Is that a word? Obsoleted, yeah. Obsoleted. And then, of course, on the far right side, where we do inference and integration, which means consuming a model, using a large language model, using a predictive analysis, a neural network, all that stuff can very easily be run on Java. And why you run that on Java is because Java is efficient. and you can run Java applications at scale. Okay, so this is kind of the base foundation for like where things currently are, and in my opinion, where things are heading. We can talk about agentic frameworks and things like that, but I don't think we have enough time to dive deep enough to do that justice. But let's see how it goes today. Okay, so we're going to cover these topics. We're going to talk about Apache Iceberg. We're going to look at a real-world app for big data. I'll show you the architecture and do a demonstration of it. And we'll talk a little bit about generative AI and LLM and things like that. And this is the application that we're going to look at today. Now, this application is, I've open sourced it. It is available on my GitHub repo. If you send me a LinkedIn message, I will point you to the repo. And I have gone to great lengths to make it such that you can clone the repo, and within 5 minutes, you're up and doing what you will see in this demo today. Because when I started working on this presentation 6 or 9 months ago, whatever, I was like, I just want to find like a little repository that has something I can just start playing around with. And there was nothing. I had to build it myself, which is fine, right? I am a code nerd, so I was happy to do it. But you could ask me questions like this, like how many houses were sold in January, and show me all the houses in the repo. We'll dive into this in a bit, okay? But before we get to that, let's talk a little bit about Iceberg. So Apache Iceberg is an open source table format designed for large-scale analytical data sets stored in data lakes. Oh, that's a lot of jargon there. So we're gonna get into that a little bit in a little bit of detail here. Okay. Now, again, the reason why I'm starting with this is because if you remember that architecture AI pipeline diagram that I showed you, you have to have data somewhere to be able to create your own AI applications, because otherwise you're creating something that is not unique and to be blunt, is not really valuable. It doesn't add any value to your company in terms of your products, right? So every company has proprietary data that they've collected over many years. How do you use this data efficiently? How do you build an AI system around it? How do you add value to your products? How do you create new products that go into the marketplace, right? As developers, especially once you move from junior to mid to senior principal level developers, you're always concerned about, how can we help the business analysts meet their goals for getting new business and making our customers happy at the end of the day, right? As software developers, we like to, we kind of get, we feel in our brain that like our art form is the end all be all, but at the end of the day, somebody pays our check to write products or to build products that they can go sell and that can pay your salary, right? And everybody else's salary at your company. Okay, that's why I start with this. Okay, so Apache Iceberg, in my opinion, is a deconstructed database, right? And what does that mean? So if you think of a typical database like MySQL or Postgres or MS SQL Server or whatever, the storage and compute is coupled with a database server, right? So you call Postgres and it has storage inside of it. The compute engine is all integrated and tightly coupled with storage. It has a very kind of not closed. Postgres is obviously open source, but it's a closed system that you're just calling into. Okay, Iceberg is just the storage layer plus the metadata that describes what's in the storage layer. Okay, and we'll talk about why this is important in a second. Okay, a little bit of terminology real quick. A data lake is storage and compute is typically less structured. A data lakehouse is storage, a table format, and compute. And so Iceberg is a data lakehouse, whereas a data lake would be something that is constructed on top of something like Hadoop. Okay, you're probably familiar with Hadoop and those other storage mechanisms that they have. And we'll talk about right here. I say that where's my pointer gone? Right here. It's structured but flexible, acid, and easier to use. We'll dive into these things in a couple of minutes. Okay, so again, visually, we want to think about what Iceberg is, right, and how you would use it as the basis or the foundation for your AI data building exercise to power your AI applications. A database has compute and storage coupled, whereas Iceberg is just a storage layer and you bring your own compute on top of that. Okay, and what does that mean? Okay, Iceberg can use any compute engine that there's libraries for it, right? And there's a bunch, right? So if we look at some of the things that are available for Iceberg, in this specific presentation, we're going to use Apache Spark as the compute engine. But there's Dremio, there's Apache Flink, Trino is like it's like a more databasey type of front end for it. And then if you're using Snowflake, Snowflake also can reach into Iceberg tables. Now, Iceberg the Iceberg data sets, the files can be stored in S3 or just on storage or wherever, right? They're literally just files. Those files typically tend to be in Avro or Parquet format. Okay, but at the end of the day, it's just columnar data that is managed by an Iceberg system on top of it. Yes.
How big does a database need? For that big data?
It's a good question. So the question is, how big does a database need to be big data? And the examples that I'm going to show here, each year's housing data is like 20 megs in size. So demonstration is not necessarily big data, but we're using big data tools. At work, I work with an extremely large data set. This is where the genesis of this kind of sample project came from, where we get 200 million downloads of our open source and free Java virtual machine called Azul Zulu. And I am the owner for those download and that download data. And so all that stuff we keep in an Iceberg table, and it's well over 200 to 300 gigs in data. Okay, so I consider that to be big data, right? But unfortunately, I don't think there's a really good answer for that or industry standard for what is a big data size, right? I think it's anything that's large.
Like, how big is a microservice?
Yeah.
How small is a microservice?
Yeah, how small is a microservice, right? But yeah, it's a good question though, right? But these things, the Iceberg is meant to be for scale. In this case, I'm not using it for scale, but it's just a demo project here, right? But the data set that I work with at work is very, very, very large, right? It's not very, 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 it's not like, you know, like internet scale or whatever the word is, right? But it's, you can imagine trying to sift through 100 gigs of data is not a small amount of data. I mean, actually, that would fit on my laptop, but it's very slow to parse all that data. So, yeah. Yes, you had a question, sir?
This may not be relevant at all to what you're planning on talking about, but I'm deeply curious about how, or even if Iceberg handles things like regional affinity. We're talking about data that's maybe partitioned across multiple regions.
Yeah, I'm going to talk a little bit about that. Okay. Yeah. Yeah. If you have a question after I talk about partitioning, please feel free to ask your question. Okay. All right. So you bring your own compute engine. Iceberg supports DB-like features like partitioning, asset compaction, snapshots, etc. Right. So if you look at these words, it's like, well, this is a database, right? A database supports partitioning, it supports asset transactability, supports compaction, snapshots, etc. But again, Iceberg is just the storage layer, right? And this came out of Netflix, and you can imagine. So every time you watch, this is what I tell people is like every time you watch something on Netflix, you're helping to create the next generation of big data tools, right? Because the Netflix folks are very generous in terms of they come up with these tools. Or these big data platforms, and then they open source them so that we all can benefit from their engineering expertise and the work they've done. Okay? But again, it's a storage layer. So when you think about this at your company, especially if you're at a large company, you have this large data, this large amount of data. You need to put it somewhere. If you put it into a database, who owns that database server? Who's going to pay for it when you query it? What happens if you have multiple people who want to use that data at the same time, right? Et cetera, et cetera. With Iceberg, if we go back to this diagram, right, you can have the storage here, and anyone can access that storage. Accessing storage is super cheap, basically free. Not completely, but you get the idea. It's not like having a database server in front of it. And then different teams can use different tools depending on what they're trying to do, right? If they're trying to do real-time types of things, they can use Spark. If they want to, if they want to run long queries across large data sets, and they don't really care that it's real time, they can use Trino and other things like that, right? But the key here is that anyone can pull the data out of, for an example, an S3 bucket where the files actually live, and then they can go run that stuff against whatever data they want. Okay, so diving a little bit deeper into Iceberg. Oh, I went too far. Sorry. All right. So Iceberg is at the top of Iceberg, you have the Iceberg catalog that points to snapshots. Those snapshots contain manifest lists, and those manifest lists point to manifest files. Those manifest files actually point to the data files. And then here we have schema contained within it. And when you go and add, let's say you're adding more data into, you're adding this week's data to your Iceberg data set. what you would do is you would create a new snapshot that would amend the manifest list, would create a new manifest file that points to your new data files. And that would not be available or made available inside of the Iceberg catalog until that thing is fully written, hence the ACID transactability. Okay, so someone can go and look at all this data and you can be writing new data to it, but they won't see it until you've actually finished writing to it. Okay, for example. So this is the general layout. We'll look at this in a little bit more detail in just a second. But one of the things that you can do is compaction, and you can do repartitioning with this. And of course, because of the way this is structured by snapshot, it is ACID transactability. So you can like basically potentially take something offline, or you can just change something and you would write new files that have like your new partition scheme in it if you wanted. Okay, so how is this efficient? You have schema and partitioning. So for large data sets, that will help. Has a schema, it can be changed over time, so it isn't rigid. This is unlike the previous types of things that people use like Hadoop, which is a little bit more rigid, a little bit hard to evolve over time, right? Because at some point you may say, you know what, we need another column, or we need to get rid of this column, or we're changing the format of this column. What do you do in that case? You basically run a migration in Iceberg and you change the data set, and you can go and get rid of the old one if the new one is the one you're going to use moving forward. Okay. The metadata helps you find what you want faster because it contains a schema and other information. And when we look at partitioning, you can repartition things, or you can partition from the beginning how you want. So you can start off by saying, let's partition by month. And then you realize that, well, it looks like we're always querying this data down at the day level. And the problem with having the data at the month level is that it will load let's say a 30 gigabyte file that contains your entire month's worth of data, and then has to filter down to that one day you're interested in. So at some point you may say, or even from the beginning, you might say, you know what? We always do queries against the day. So let's repartition it so that it's basically by day. So instead of pulling 30 gigs of data from S3 storage, you pull 1 gig of data. Okay, so that's where the efficiency and performance comes in. Now, the problem with doing this versus this is that you get fragmentation. So let's say that you want to query 5 days of data, or you want to look at 2 weeks worth of data. Now you have to pull 14 files, and whatever compute engine you're doing has to take those files and merge them together or do multiple queries against them. So it's less efficient, i.e. it's fragmented. Like if you think of database technology, one of the things that you have problems with databases that you try to fix is you try to you basically try to defragment your data, or you try to do compaction to make it more efficient, right? And you can do that kind of stuff with Iceberg if you want, because you, the developer, has the flexibility of doing that. Okay. Yes, sir. Go ahead.
So it's like watch this stuff. Is it like that sort of when you say data? It's like companies can watch this stuff.
Yeah. So the data can be anything you want. Okay. So if we use the Netflix example, what they do is they track what you want, and then but that's not the end of it. Watch what movie you want. They're keeping track of what movie you want. You watched 5 action movies last week. They know that. That's where the recommendation engine comes in and says, oh, you watched 5 action movies? We suggest you watch this movie this week. Right? But they have a ton of data, like this, and there's all sorts of different things. There's TV shows and movie. Right? You like watching Squid Game, so like we'll recommend you Korean movies or TV shows, right? So they have all this data that they slice into different ways. I'm just making this part up, to be honest with you. Okay? But I'm just trying to, well, I don't know exactly how they do it, but I know I watch Netflix and you know, I see the different recommendations and stuff like that, right? Yeah, good. No, it's I don't know what Netflix is doing currently or how long they've been using AI, but I'm pretty sure they had most of this stuff before like AI was a thing. What's that? Yeah. Right. So I don't know, right? If they're doing that. Okay. Good questions though. All right. All right. So we talked about this stuff already. Multiple apps can use the same data sets. You bring your own compute, possible to evolve schema and partitioning and ACID transactability. Each change that is a snapshot. You can do things like time travel, and you can also have it fetch only the files that it needs based on the partitioning scheme and by looking at the metadata and stuff like that. We're going to look at that in just a second. So you do need to have a catalog server. That is the thing that Iceberg uses to manage your data. There's Apache Polaris, Lakekeeper, which is we're going to use in this demonstration, and there's AWS Glue, Hive, and then Snowflake also has a catalog server built inside of it. I'm using Lakekeeper because it's super simple and super lightweight. Apache Polaris seems to be where the community is kind of moving in terms of an open source catalog server for Iceberg. Okay, but a lot of people use Snowflake because it has a catalog server, and if you're on the Snowflake, if you use Snowflake at your company, it has like all the little things, and it just becomes part of your Snowflake instance. Okay, and we're gonna look at this. What's in the catalog server? Namespace, tables, and schema. Okay, so let's do a quick demo. Have a look at some of these things real quick. Right, so again, we're still on the Iceberg part. We'll move on to the more fun stuff in just a second. So this is Lakekeeper. Okay, let's go to home. I've already logged in. And again, Lakekeeper is the catalog server for Apache Iceberg. Let's look at our warehouses. I have one warehouse that I named Lakehouse. Inside of that, I have my housing data. And then if I go to my tables inside of the housing data, right, I have my table called prices. And then here is the transaction ID, the price of a house sold, when it was sold, the data transfer, postcode, the town, locality, district, etc. Okay, so this is my schema basically that I'm looking at in my catalog server. Yes.
So, what would keep points and something like that?
What's that?
What would in-house prices?
Why is it an int? So what I did is this is an open data set, right? And so in the open data set, the price was in there as an integer. Okay, so I have a Jupyter notebook that that's part of this, which I'm not going to show the notebook itself. I'm going to show all this stuff running inside of Docker in a second. But yeah, this is basically a data set that I didn't come up with; it already existed. And I found somebody who had done like some stuff with it. And I was like, ooh, this is perfect for the kind of demo app that I want to do, because unfortunately I'm not able to show you what I use at work, which is using Iceberg to look at, that 100, 200 gigs of JVM download data for our open source Java virtual machine. Unfortunately, our lawyers would not allow that quite yet. So
Yeah, sorry, but
Yeah.
typical remote system, would that be trade-off? Using prices of it?
right, so we're talking about house sales, right? So house sales for like $100,000. So typically, when you buy a house, it's not $100,000.50. It's just $100,000, right? The seller will usually give you that 50 cent. I'm just kidding, but it's at that scale, it doesn't matter.
See the capacity of the integrator.
Yes, that's right. It's
When you shable bill.
No, the capacity of the.
yeah. What's the maximum size of an ant? Like 32 billion?
Yeah.
2 billion. Yeah, right.
No, I was gonna say because if there was a fraction anyway, because of the tax or something,
Yeah.
would that shave it off?
Yeah. It would just be, well, it depends on how you put the data in. Again, this is data that you populate. When you run this demo, you'll populate the data into there. So it can be up to you how you do it. And you guys correct me if I'm wrong, but when you fill out like tax forms, that's also rounded up to the closest dollar, isn't it?
Yeah.
Okay. Just making sure I wasn't crazy. So yeah, even when you do taxes, it's always just rounded to the closest dollar. It's never cents.
Real estate agent, I can't see any downside just going out to ChatGPT or Cloud or something and saying, hey, give me 20 terabytes or however much of housing data that follows a normal distribution pattern for the US market.
Yeah. Yep. So, all right. So this is our Lakekeeper. This is again the catalog server that's in Iceberg, and this data is pointed. The actual data is in Minio, which is essentially a S3 object server. It's like S3 on Amazon or AWS, but it's just an S3 server that has the same S3 API. So here's my warehouse, my housing data, staging, and here's my metadata. These are the metadata list. If you remember from the presentation, that is this stuff right here. The manifest list and the manifest files are in here, right? So and the data itself Actually, this is not the data, but you can see that this says metadata, metadata.json, and this I believe is also metadata.json. But if I go back, I didn't load up the entire data set for the last 30 years that they provided, but you can see here the two Parquet files for 2024 and 2023. Okay, but the key thing to remember is that our metadata, our manifest files point to those data files, and then the manifest list points to those manifest files. So this is how you go and get it. We're going to run some code in a second and actually reach into the Iceberg data set and pull that up. So
Good question. Is each file what we would say a table, or is one file, could it have data for, say, n number of tables?
yeah. So typically, this is kind of up to you in some ways, but you can have one ginormous file that has a whole bunch of stuff in it. But obviously that is not the recommended way of doing things, right? You don't want a 10 gig size file, for example, right? You probably, I don't know what the right answer to this is, but you probably want something a bit smaller, right? But I think it's more about how you partition it than anything else. Right. So if you partition by day, you're going to get smaller files, and you want each file to represent a day. Whereas if you partition by month, that one file could, a single file could potentially represent that whole month, depending on how big the data you're actually stuffing in there is. Now, I don't remember exactly off the top of my head what Iceberg does if you have like a huge amount of data, like if there's a limit and says, okay, every file for this snapshot the maximum is like 1 gig in size. I don't remember the answer to that question. Okay, yeah, that's a good question though. All right, so let's get back on track. We did a quick demo of that to show you what all this stuff looks like. Now what I'm going to do is we're going to get into the demo application. It's a little real estate analyst app. And we're gonna ask it these questions. I'll take some audience questions in just a second, but let's talk about how this is structured. We've talked about Iceberg for quite a while now, so hopefully you're at least familiar with what it is. It's a stable format. We looked at the Lakekeeper, what some of the files look like, etc. We're going to use Spark as the compute engine, and we're going to use AI here for taking a English language question and converting it to a Spark QL query. Right, that's where LLM gets it fits into the model here. Right. And again, the best part about this is you can easily run this all on your computer and experiment with it within less than 5 minutes. Okay, so we're using Spring Boot and Spring AI and Apache Spark. I've integrated a single node Spark server into Spring Boot. That's probably what took me the most amount of time to do. It didn't take me at all to write the code. The reason for that is Spark is meant to be run out on its own. But again, for demonstration and experimentation purposes, I want everything to be integrated so it's super easy to run. I'm using a Llama to run a large language model locally. And then the Docker container contains Iceberg, Minio, and Lakekeeper. So if I flip over to my Docker container, you can see here, let me zoom in a little bit. Here's my Lakekeeper running. Here's Minio. There's also a Jupyter notebook, which there's like a base project I use to build this project on top of. The Jupyter notebook has Python code that you can execute to go and populate the Iceberg tables and do a bunch of stuff, right? It's basically like almost its own mini tutorial. There's a big database server that backs Lakekeeper, and then there's also Trino in here, and I have a separate a Docker Compose file, which also includes Kafka. So if you want to do that AI pipeline thing, you could take your data that's coming from Kafka, you can send it into this Kafka server. Where's my trick? You can send it into the Kafka server, have the Kafka server populate an Iceberg data set, basically doing like almost your whole end-to-end kind of application for building an AI application. Okay. All right. So a standard warning, don't deploy to this production. I've embedded the Spark system in the Spring Boot app for ease of development. That is not how we run Spark in production. Okay. So hopefully most of you know that. Okay. If you don't, you don't know. All right. So let's have a look. Let's take a step back one more time. So this is, I just created a simple a simple web interface to run this stuff. this is just getting the catalog. So if I reload this, it loads really fast because I already have it running. And then here is an endpoint I have, and this is all just Iceberg stuff so far. Well, this is Iceberg being called from a Spring Boot application. I'm just showing the first 10 rows of the table. You can see that changed when I just reloaded that. And let's go look at the code for this very quickly. Okay, so if I go to my Iceberg controller, how did I get the catalog information, or how do I get the catalog? I say properties. Oh, okay, excellent. Let me back up first. Right, so if I go into here and inside of my project, let me move this out of the way. You can see I have Iceberg Spark runtime. So there is already a pre-created Iceberg plugin for Spark. That's what I'm using here. That's how it knows how to talk to Iceberg, how Spark knows how to talk to Iceberg very specifically. Okay, so if I go to my Iceberg controller, I go and set this URL. That URL may be familiar to you because when we were looking at Lakekeeper, you can see here's localhost 8081, right? So we were looking at through the web interface. This is using the API interface. Again, if you remember when we looked here, warehouse, lakehouse staging, lakehouse housing staging prices. Here is, I say this is my lakehouse. The namespace is housing. The table name is staging pricing, right? So there's all stuff we looked at through the web interface, but this is how I'm configuring my Iceberg Spark plugin to talk to Iceberg, okay? And then I say, go and get the table. And now I'm going to catalog.load table, and this will go and get my table. And then so far, I'm just printing out the metadata, and you can see the last thing that I printed out was the schema. So if I flip back to here, you will see that the table location is S3 colon blah, blah. That's our Minio S3 server that we were looking at. Okay, this is the table location, right? Which again, we saw here in our Lakekeeper where Iceberg catalog is pointing to. And then I just printed out the schema just to make sure that everything looked good. Okay, so this is how my Spring Boot application is reaching into Iceberg and pulling out the metadata. Now, how did I actually get the information? That was the show table. And again, that's this guy right here, where I'm just showing the first 10 rows. And my table name should be familiar to you by now, Lakekeeper housing staging prices. That's exactly what we got from the catalog server. And this is where a little bit of, I have a little bit of a diversion because I have stuff wrapped in a Spark config file here. And this is where I configure my Spark configuration to basically go and be able to pull this data and also write this data to Iceberg if I want it. Okay? So you can see I have the implementation. It's pointing to the catalog server right here. So it knows where to get the manifest list and the manifest files from, which will point it to the actual files that Spark will then pull in, and we're going to run queries against. Okay, and you can see right here, we specified the lakehouse and our server. Now, if we go back to our Iceberg controller, I say here's the Spark config, and then very simply Spark. I've already loaded the config right here. Right, I say Spark read the table and our table name, and our table name is as specified here. Okay, so that's how we were going and getting the catalog. The catalog has our schema. It also points to where the actual data file is. That's how Spark knows where to read the stuff from, and it's reaching out over the S3 connector. That is, I believe I have it configured in here, right? So I have the S3 AWS SDK in here. Even though I'm not reaching to AWS, I'm reaching to a local S3 server called Minio. It uses the same library because Minio is API compatible with it. Okay. Anyways, quick flyby of that. All right. So let's get on to the more interesting stuff now. And let's actually go run our application, which is here. Okay, let me reload this page. So let's start with a simple question. I have some already loaded in here. Let's start with a simple one. Show me all the houses which were sold in the town of Birmingham. Now, again, this is the United Kingdom housing data. I think like the last 20 or 30 years of this data is available. They have it like on their government open data website or whatever. Okay. Not Birmingham, Alabama, Birmingham, England, specifically in the Midlands. Okay, West Midlands. So I used to live in London, so I know exactly where this is. I've actually been there, right?
really, really good Indian food there.
Yes, yeah. It's surprising to say that the best Indian food in the world is not in India, is actually in England. So I will die on that hill. Okay. I've been to both places many times, right? And I prefer the Indian food you can get in London or in the Midlands specifically. Anyways, so what this is going to do is this is obviously written just in English, right? In natural language. Now, the goal of this is I'm going to run this, and what this will do is, hold on, let's see which, I'm going to explain how the AI stuff comes in here in just a second. Basically, we're going to use AI to go and take our English language question and convert it to a Spark QL query. Okay, because again, the way that this demo application came to my head was I have this gigantic data set at Azul for all the JVMs that are downloaded. And occasionally, well, every quarter I get questions. How many versions of JDK 17 were downloaded last quarter? What were the different JDKs downloaded? And eventually, I had to go and manually go and put it into AWS QuickSight or load this into Spark and then run all these queries and write it all by hand. It was very time consuming. And like every good developer who's super lazy, I automated myself out of that specific tedious job, right? That's what good developers do. Okay. And why is this not working? Let's see what happened here. Uh-oh. Connection refused. I'm not running Olama anymore. But before I do that, okay. So let me explain this while this is firing up. Let me start Olama. So Olama is a system, and that's not good. Why did that not come up? Oh, that's weird. All right, this is going to be a short demo. Thanks for coming, everyone. I'm just joking. Let's pull up. That is so bizarre. Go to applications. That's weird. My Finder is not working. Okay, we'll do it the old-fashioned way. Okay. Now Olama is running in the background. I can drop to the command line. If you're not familiar with Olama, Olama is a software package that you can use to go and run large language models on your laptop or on your computer or on your server, wherever you want. Now, these are the different large language model base files I already have downloaded onto my computer. We're going to start with using this one right here. So this is Gemma 3. Gemma 3 is Google's freely available large language model. This is the 27 billion parameters running at Q8 or quantization level 8. Okay, so this is the one we're going to use. Let's go start this and let's see if it's already loaded. We'll do Olama PS. Olama is not running an LLM right now, but as soon as I click this button, stop it and restart, make sure everything works. As soon as I click this button, what it's going to do is, and I'm going to show the system prompt and the Spring AI code for all this in just a second. When I click this button, generate query, it will go and make a call to Olama to convert this from natural language to a Spark QL query. Okay, so if I go now and do Olama PS, you can see that Java 3 is loaded into my system. And it takes a second to load this because it's 33 gigs in size, which is quite large. I have 64 gigs of RAM on this laptop, but this runs reasonably well. Okay, now, so it's taken our query and it's converted it to Spark QL. Okay, so and that looks approximately right. Select star from lakekeeper.housing.staging prices. Remember, that's where our Iceberg table is. And now let's go run this query. So now the second step is just calling Spark and saying, go run the Spark QL query, okay, against this data set, which I've specified here. And you can see here's our data. Okay, I'm only showing the first 10 rows, okay? Now, how is the first step for generate query working? Let's go look at that real quick. Okay, so if I go to my AI service, I have, actually, let me start from the beginning, okay? pom.xml, let me look at, Olama. Okay, so in my project, I have loaded, I have specified a dependency and get out of here. Spring AI starter model Olama. So this is the Spring AI library specifically for Olama. You can see I also have the one for OpenAI down here commented out. So you can use OpenAI. It supports Llama, it supports practically every large language model that's available out there today. Now, the way that it knows how to configure this is in my application.properties. Because I have that library loaded, it will look for Spring AI Ollama configuration. I say the base URL is this. I'm running Ollama locally. And then which model do I want to use? Gemma 3, which if you remember, that's what Llama was running right here, right? So this is the kind of configuration magic that Spring provides. I assume everyone in the room is familiar with Spring, right? Now, how does this actually being used? If I go into my AI service, I say chat client.chatbuilder.build. That goes and reaches into the config file. It says, oh, you want to use a Llama. This is the model you're going to use. This is why I'm going to connect to it. That's when it will connect to it. And here's my system prompt, which I'll come back to in just a second. But to actually make the invocation, I say chat client. Here's my prompt. Here's my system prompt, my user prompt. Call it with the system and user prompt and set the chat response. I take the chat response, I get the result, get the output, get the text, and then I return it and show it in the web browser. That's exactly what I was doing, okay? Now, what is a system prompt? Right? I assume everybody in this room has at least played around with some AI, right? And knows what a prompt and some basics are. Okay, good. All right, so what's that?
You hear right now?
Yeah, that's right. Exactly. So my system prompt this is the system prompt, by the way, not the user prompt. You are a database query assistant. You're going to take a user's question and construct a Spark QO query from the question. Don't give me the explanation, just give me the query. I don't want the output to be escape. Some language models like Gemma 3 will try to make it in Markdown or do escaping. I just want the raw query so I can just feed it straight down into Spark QO. The table name is this. Now I've hard-coded this. In future iterations of this, I will change this, but I'll talk about that in just a second. Make sure the query accommodates for case insensitivity, hence why you saw this in here, lower, okay? I want to return all the results. The query should only include columns that are in the table. The table has these basically the columns indicated in the user prompt. I'll tell you why I did that in just a second too. But let me ask this question. Why do you think I included this in the system prompt? The query should only include columns that are in the table. Take a guess. What do you think? Exactly right, right? Now, you are 100% correct. That is not foolproof. And we will try to break this in a few minutes, okay? You're 100% correct, right? But if there's nothing else you gained from this session today, except for this one thing, which is large language models and generative AI is inherently non-deterministic. You can turn down the temperature to reduce the non-determinism to make it more deterministic, but you can never get to zero. Basically, you can never make it completely deterministic or zero non-deterministic. It is impossible to do that. You can get it to 99.9999, whatever, right? I don't know what the exact dot nines would be, but I think this is what frustrates most people when they first come to start using generative AI stuff and try to build apps with it. You feed it something in the context and it just comes up with something, or it's the wrong thing. It's like, what's going on? Am I crazy? You're not crazy. This is just how large language models work. In fact, in the application.properties, you can see I have this commented out, right? You can see I can turn the temperature down. If you're not familiar with what temperature does for a large language model, 0 means that basically don't be creative. If you set it to 1, that means be very creative. So to make things more deterministic or inversely less non-deterministic, you can turn the temperature down. That will hint to the model to don't be so creative, don't make stuff up, right? Kind of thing. But again, it's never 100% deterministic. Okay, yes. Yeah. Sorry, say that.
Can you use?
Oh, yeah.
This scenario.
Right. So RAG is a technique for augmenting a language model. So what we're currently doing here is with this system prompt, we're actually trying to get the LLM to construct a SparkQL query from it. Okay, so there's no RAG in this picture at all, right? But I'll answer your question anyways, right? You can use the temperature if you're building a RAG system to try to make it more deterministic and less have less hallucinations, right? Absolutely. Is it still foolproof? Absolutely not, right? RAG is just a way of it's just a way of doing context stuffing by providing the answer to the potential question that is being asked by the user and just stuffing it in the context, right? So you could put that in the user assistant prompt. RAG is just a better way of doing that rather than just doing a database query and then feeding it in there, right? It's a more automated way too. So yeah, okay. All right, so now where's the table? So the user prompt is, here's my columns, which I'm going to show you in just a second. And here's the question that I typed in the little window in the web browser, okay? And what do I have in that that user table? Basically, I took the schema and I copy and pasted it here. Now, if you look at this, right, you can see I don't just have postcode, required string, blah, 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 right? I left the description in here, right? So for example, I have, right, whereas the property has been divided into separate things, but if we look at, let's look at one of these fields, right? So in the UK, right, the property type, so detached would mean in the US would mean a freestanding house. Semi-detached would mean two houses which are basically a duplex, but it's two residences. Terraced means basically like a row of homes or townhomes, right? So they use slightly different nomenclature, but I left this in here because what this does, and a flat would be like an apartment or a condo, okay? But I left this in here because this is fed into the user prompt. And when this is fed into the user prompt, if the user asks a question like, show me all the houses which were townhomes that were sold in Birmingham, it would be able to look at this, and I've given it enough hints for it to know that when I say find me all the townhomes, it will correlate townhomes to be a terraced house, right? Actually, I should probably also include T equals terraced or townhome if I wanted to, like, but most large language models will be able to discriminate between detached, semi-detached, and terraced and flats and convert that from English to American English, which were the things I just said, right? A flat is an apartment. Large language model is very good at that kind of stuff, right? Good at finding synonyms, right? And also contextual things. Like, if you say something like, he gave a speech on the lawn, it would recognize that he gave a speech on the grass as the same thing, right? Grass and lawn are synonymous in that context, but LLMs are good at doing that. Okay. Anyways, so I provided all this information. That's how it's able to do this. Okay. So let's just wrap this up really quickly, or this specific explanation really quickly. Let's go to our controller. And this is not very fancy, right? This is generate query. It uses our AI service, and I pass it the question. And then I'm basically just slapping the result of what we were just looking at in the AI service. Again, this is how we're calling it. Here's the system prompt. Here's the user prompt. Call it, get the chat response, get me the text, return it, and then show it in the web browser in here. And then when I click run query, again, not super complicated. It's a simple controller. Sorry, wrong controller, right? Run query basically just takes what's here and grabs it. And right here, it does spark.sql generated SQL, and it goes and runs it. Okay. And then I'm just showing the information and returning it back to the web browser, and just basically just showing it in the web browser, right? Relatively straightforward. Okay. Now let's do something fun since we're nearly at the end of this presentation. Why don't you all give me some queries that we can ask this thing? Okay. Let me refresh your memory real quick. This is what the data looks like. Transaction ID, price, when it was sold, the postcode, i.e. the equivalent of a zip code, the locality, town, district, county, etc. Okay, so anyone want to volunteer a slightly more complex, pretend like you're a realtor? Yes.
What's the market dollars for terrorists?
I don't know if it'll understand volatility. Yeah, because the system prompt is very specific here, right? If I go back to the system prompt, I tell it that you are a database query assistant. So at this point, the system prompt will only know, it only thinks it should be, its task is to convert English language to SparkQL. But you bring up a good point. Well, that would, if I wanted to ask a question like that, then I would create a separate, I would create a separate method with a different system prompt. And then I would basically do some stuff, and we're kind of moving into the agents and agentic AI kind of stuff, where what we're doing is we're calling the LLM to decipher the question, and then the agent would say, oh, you want to know this about this. I need to now construct a query. So the second step would be this in that case. But yeah,
What's the difference between what you've implemented here versus using something like maybe an MCP? that connects
okay.
with
Yeah.
the UI?
Yeah, so that's a great question. So but the next step that I am currently working on for this demo app is not having the stuff quote unquote hard coded, but me and a friend who's a Spark expert are actually working on building a Spark MCP server. Right. So you're like one step ahead of me on all these things, which is great. So I'm not hating it all, right? But and we're working on building out a Spark MCP server. That Spark MCP server will have a few actions. One of those actions will be this: take this English language question, create a SparkQL query from it. It will have MCP resources, which is like, these are the tables that are available. If you remember, I have the table hard coded into here. That is not a good thing. What I want to do is I want to take that out of the system prompt, and I want to include it in the user prompt, so that I have the flexibility, so that the agent or the MCP server can respond and says, oh, you want this table, right? So I could ask it a question, and I could say, which table or which Iceberg data set or which table contains my housing pricing data, which table contains my car sales data, right? Then I can have multiple different data sets in there, and it will know which data set is which, and then it can be IE agentic, and it can like basically do multiple steps for me, right? But we're working on MCP server. The other component of that would be actually running the query, which is that part that I showed. It'll say, oh, you want to run this query? No problem. You've given me the data set, the table name, etc. I'll go run the data with the query you've just given me, right? So that'll be another action in the MCP server. So it's a great question, and that is basically what I'm working on as the second step to this. So
Sorry.
yeah.
This guy is pushing this whole thing to Olama, right? And Olama is doing the job and pushing.
No. So the only thing that Olama is doing, okay, so it is taking this information. This is the user prompt. This is the system prompt. It's taking that plus the user question, and it's giving it to the large language model running in Olama. And it's basically saying, you're a database query assistant. Here's the user's question. Convert that question to SparkQL. And it is the LLM that is taking this question. Well, let me just taking this question, and it's using the LLM's neural network to produce this output. So it's converting English language question to a SparkQL query.
Basically, like after
So
natural language, which is not
Yes.
deterministic, to structured query language, which is deterministic.
Yes, exactly.
GraphQL point that's discovered.
100%. You can also do it for GraphQL.
So back to this question now. So I think the it's good at what is trained at, right? So
Yeah.
back to this question about volatility down. So if I pass the question to Olama gets stuck, no, so nothing.
Yeah. So with Gemma 3 loaded, I could actually ask like what Jim was asking, which what was your question again, Jim? What is the market volatility
That's month.
in the past month for houses in, well, let's keep it easy for now, right?
Yeah.
Let's just do this. Let's see what let's try it. I don't know what's gonna happen. It's the first time I've gotten that kind of specific question. So let's see what's happening. It's going and hitting the Gemma 3 right, and it will eventually return something, I hope. So what happens with Olama, and this is configurable, is that if you noticed right here at the end, it says until 3 minutes from now. So what a llama does out of the box is it only keeps a large language model in memory for 5 minutes, but that is configurable. Okay, so the reason why it's slow right now is because it's reloading it from disk. It's loading 33 gigs into disk. Okay, so now it's returned something, and let's see what it returned. This will be fun, actually. Remember I was saying earlier that I have that statement in there said, do not escape this data? Well, guess what it just did? It added the escape tags. Okay, so again, it's non-deterministic. You never, I know how to fix this. Actually, when I gave this recently, one of the members of the audience was like, "Oh yeah, that Gemini 3 is trying to force it into Markdown format." So I think I need to adjust the system prompt and say, "Do not give me in Markdown format. Give me just a clear text or something."
When working with cursor, you might also have modifiers like never or always or that kind
Right.
of thing that might get you better results, but there's really no way to completely make that.
Yep. All right, so let's see if Jim's question, select price, common data transfer. No, it totally, it didn't understand volatility at all. It did, it did, it did. It did. But I think I think this may be a little bit, and I'm not trying to be hard on you, Jim, but I think this may be pilot error because we asked it a very vague question.
Yeah.
Right. Well, what does market volatility mean in this context? Right. Yeah,
So what's volatility? Is it the variance or the standard deviation?
exactly. That's we were too vague about it, right?
Yeah. Also, but I think we phrased it to variance with that.
So with this fallback to property generated on or
How about this?
Yeah, so that's right.
Let's try it. Let's see what it generates. Okay, and again, it's out, it's escape, but that's okay. No, it gave us the same thing. It just didn't understand it, right? But again, I think the way that we would solve this problem or create this feature is we would do 2 steps. We would use a different system prompt to say, you are a market analyst, not a database, a database query assistant, right? What was the prompt we used? Yeah, database query assistant. You are a real estate market analyst. You're going to take the user's question and I don't know, you're going to take the user's question and we're going to come up with ways of exploring data that looks like this or something like that, right? I'm just making this up off the top of my head, but I think that's how we would start off writing a system prompt for it to be able to take that, understand it, and then output me something which then I could pass down to the database query assistant that would then take that and convert it to a SparkQL query. Okay, now let's try something else here. Let's see, does anyone want to try something else before I just anyone want to? Yeah, go ahead. Go ahead.
Top 10 or top Houston sold.
Okay, well, this is the UK, but so let's see, what are the top, what are the top 10 housing markets?
What are the 10 priciest homes?
Okay,
10 differences in the so
sure, why not? A Birmingham, as they would say over there. Okay, let's go run this query. Let's see what this gives us. Okay, I know it's still escaping it. Okay, that's actually correct.
Yeah.
Okay, so let's go run it though. Let's just make sure. Okay. Okay, run query. And that did not work. Why not? Okay, let's try it again. Maybe I need to get rid of that.
Space. True to 8% of that leading space shouldn't
No, it shouldn't matter. You're right. Okay, let's go generate this query again. Let's see if we get a different result. It gave us the same thing. I wonder why that didn't work. Okay, so this is actually a perfect time to try something different.
what did you say, 10 highest prices ordered by price? Those with 10 highest price.
What are the 10 most, what would you say?
Well, 10 highest prices.
It'll probably return the same thing, but let's see what happens. Same thing, same thing. Okay, but let's try this, right? This is, again, this is the fun, it can be fun to experiment with. So I'm gonna stop this. Let's change from Gemma 3 to Qwen 3 coder. Qwen 3 is the set of large language models from Alibaba, if I remember correctly. And Qwen 3 coder is actually one of the best at coding. So the problem with Gemma 3 for our specific use case right now is that Gemma 3 is just like a general model that includes like some coding stuff in it, right? Whereas Qwen 3 coder is what we call, I'm going to forget what it's exactly called, but it's basically a specialized model that is distilled down just with the coding part. Okay. What's that? No, I don't think it's called Codex, but it's basically, it's a specialized model. Now, if I look at my Olama list here, you can see Qwen 3 coder is 18 gigs in size, but all 18 gigs of that is specifically focused. Basically, that neural network has been distilled down to just the part that's for coding. Okay. Whereas Gemma 3 is a general purpose model, which is 30 gigs in size, but it includes everything in it, right? Like you could ask it like, write me a poem, or, when did Lincoln give the Emancipation Proclamation, or whatever, right? Whereas if you ask Qwen 3 coder that, it'll be like, I don't know. I'm just a coding thing, right? But what's that? Yeah, Qwen 3 is available as a model for cursor too. Yeah. And this specifically, I believe, I don't remember the quantization level I'm running on this. I have a Mac Studio at home where I can run much larger models. Up to that Mac Studio has 512 gigs of RAM in it, so I can run the Qwen 3 coder, which is I can run the 400 gigabyte model on that thing. It actually runs reasonably well. So, anyways, let's try this other model. Let's see how it works. Okay, we're near the end here, so I know it's late. Everyone probably wants to either go to the bar or go home and go to sleep or something, but let's try this. Okay. Actually, let me make sure that the other model is not running, and it is. So I'm going to stop that because 30 gigs plus 20 gigs is 50 gigs, and that will crater my laptop, which would not be nice in the middle of a demo. Okay. So I just stopped it. And now I'm going to go and let's just clear all this out to make sure that, okay. What are the 10 price homes in Birmingham? Let's hit generate query. This is now calling Olama. Now, if I do Olama PS, now I have Qwen 3 coders loaded. Okay, now if I go back to here, let's see. Select star from blah, 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 where lower town equals Birmingham. So you can see it did not ignore my system prompt. Order by, let's just run it. Let's see what happens. Okay, I just restarted everything, so it's reloading the data set into memory. Okay, and boom, now it works. Okay, so it actually worked this time. But
Well, I wonder if it was the case sensitivity that torpedoed it.
it was the case sensitivity that torpedoed it. I believe you are correct. Okay, so this is a good time to talk a little bit about like large language models, whether you're using it for coding or for like just business applications or whatever. I say that every large language model has a different personality, right? And you have to learn that large language model's personality, right? Yes, exactly. And sometimes many are annoyingly too helpful, and they will try to please you even when you tell it not to. It's like, if you don't know the answer, tell me you don't know the answer, and they'll still give you an answer. It's like, no, just if you don't know the answer, don't tell me, don't give me some crap, right? Anyways, these large language models, they have different personalities. In this case, I was just using them locally. I typically end up using for day-to-day use and for coding use, I use different ones. I use Anthropic, Claude, Sonnet for a lot of coding tasks. I also end up using Gemini quite a bit. I find Gemini 2.5 Pro to be very good, especially at Java stuff. That's the one that I have my IntelliJ Copilot plugin hooked into the Gemini model. But I have some friends who like ChatGPT and they swear by that, right? Each model is slightly different. There are different context windows, meaning how much can you stuff into them and stuff like that. And I think probably the biggest thing that I would like to imprint on you today is that we're extremely early in all this AI stuff. Okay, so and this is one of the problems today is that because certain companies have invested way too much money in all this stuff, there's now when the economy of the U.S. invests trillions of dollars into one specific technology, some kind of return has to come out of it, right? But that return, in my opinion, is very far down the road. So when I say very far, I mean not like 6 months or a year from now, but like 2 to 5 years out. So
Yeah, you know, the US government is engaging in fundamental research at a scale that's never been.
yeah, that's right. And a lot of this, with Project Stargate, you and me, the taxpayers, are pouring money into this stuff.
Yeah.
Right. But even if you put that aside, it's extremely dangerous what's happening because when this technology is not proven, there's no like proven ROI for this stuff yet. Okay. The reason why I'm saying that, I'm not trying to get on my my economist soapbox and tell you that everything is crap. I'm just saying that you have to temper your expectation when you build these AI apps, but more importantly, you have to have guardrails and you have to have ways to test it. So what I mean specifically is that next year, because everything is moving so fast, not even next year, 6 months from now, OpenAI will come out with ChatGPT 6. Okay. But every AI has its own personality. You're using ChatGPT 5 today to build out this business application. What happens when ChatGPT 6 comes out? Will it work exactly the same as it does with ChatGPT 5? I would bet $1 million that it will not. Okay, because it will have a slightly different personality and different characteristics. So what you would do for that, and I'm just going to bring up the last slide here, and we'll talk about this for a few minutes. Okay, I've covered everything that's in like these slides. We talked about loading stuff. We looked at the system prompt. How do we get more rows? But this is what I wanted to get to here, right? And it's the last bullet point here, is that there's this emerging kind of best practice or whatever you want to call it right now of writing unit tests and also using AI. Specifically, the term that people use is called eval, EVAL, for testing the output of your testing your AI application to make sure that it's correct. So basically, what that means is you use a LLM to test the output of your LLM application. Okay, you may use the same LLM or you may use a different one. You don't know, right? Or I mean, it's up to you. Sorry, not you don't know. It's up to you. So you may use a expensive large language model like ChatGPT 5 for your actual application, and then you may use ChatGPT 4.0 mini to actually test it because it's just testing it. It's not doing like that. I just made that up. I don't know if that's the right thing to do, but it's called evals. This is an emerging part of this whole thing. And in the latest release of Spring AI, which came out like a week ago, which is I haven't had a chance to put any of this stuff in yet. They actually have an eval framework built into the new version of Spring AI 1.1 milestone release 3, which literally came out like a few days ago. Okay, so we're starting to, my point is, right, starting with the big level picture, we've invested so much money into this, and there's like all these inflated expectations of all the returns or cost savings or new businesses it's going to spawn. And then if we kind of go all the way down, all this stuff is changing very fast. If you're building AI apps, you have to have guardrails, you have to have lots of tests, and you have to be thinking about things. We're very early in all this cycle. That doesn't mean you shouldn't start considering or even start building things. Again, it's up to your business. I was talking to somebody from, I don't want to say the name of the company since this is being recorded, but I was talking to somebody who, or a group of people at a conference recently, and they are building probably one of the best uses of AI applications I've seen, basically taking large amounts of analyst data that normally would need to be sifted through by other analysts and condensing it. And so instead of having, 10 or 20 analysts spending a month on something, they can reduce the amount of time by using AI with summarization and by doing checking and stuff like that, using, again, the LLMs, from 20 people spending a month doing this to 5 people spending a week doing it, right? And it was like a real use case, and they're using it in production today. Okay, so people are building things. I don't know how they're going to accommodate for the fact when, you know, these models change, new models come out, and all that kind of stuff. But anyways, that is the end of the presentation. So we'll take some questions, but I'll leave this up. If you're interested in the slides or the code demo, you can reach out to me on LinkedIn. It's super simple. It's /in/PR Patel. Also my Twitter handle and also my Blue Sky handle. But yes, please reach out over LinkedIn. Happy to send you the demos or to send you the code repo so that you can play around with this yourself. Okay. And we have a little bit of time, so I'll take a few more questions and then we can all head out of here. So, yes.
So, right now, TypeScript, so how easy is it to convert over to Java? Is it like
To JavaScript or TypeScript, yeah, it should be raw TypeScript.
so syntax for TypeScript, syntax similar if I'm still on progression from TypeScript. Okay.
But you wanted to work
someday. Maybe for partners.
right.
And you go Colin or speak to Colin in Java.
Yeah.
It's called
It's just like with Java today.
it's called Visual Studio Code.
Yeah, that's just how you
Okay, yeah.
So providing this TypeScript, there is a lang chain for J equivalent. So the two competing frameworks in the Java ecosystem for doing generative AI inference is Spring AI, and the original is not the right word, but the one that's been around longer is called lang chain for J. And there is an equivalent for lang chain for J for JavaScript, or sorry, lang chain is originally written on Python. Then it was converted and has kind of forked away from LangChain Python to LangChain for J, specifically for Java. There is an equivalent for LangChain for JavaScript. I don't know what it's called, but it's available in the node repository. So I've seen people do stuff with it before. That's probably what you want to do. And you can basically just steal. Yeah, and you can take the system prompt and the user prompts and just stuff them in there. You don't have to write all the boilerplate code around it, because obviously this is in Java. But this is a really simple call. All I'm doing is giving it a system prompt, a user prompt, and I'm saying go run this, right? So that literally, if you're using LangChain for JavaScript or whatever it's called, it'll be like 5 or 10 lines of code. Okay. All right. More comments, questions? Comments, questions? Anybody else?
It's good.
Okay.
So I thought I knew what a unit test was. I'm thinking about like AI models that are themselves unit tests. Like, how does that?
So specifically that's called eval testing, right? So you still have unit tests. Okay. An eval test is like a unit test, but it uses an LLM to verify whatever it is, right? It doesn't have to be the output from an LLM, but that's the general idea. I mean, if you wanted, you could say, you know, this method adds two numbers together, right? Here are the numbers. Will it work? You could. It's basically it's entirely up to you as a developer, right? But the only real difference between a unit test and an eval test is an eval test uses an LLM to test whatever it is that you're trying to test. That's all it means.
So it's similar to what we just did now, I think.
Well, there's no unit test or eval test.
Like an eval test because we have volatility called.
Yeah, that's right. What we did is we used our brain as the unit tester, right? We said this is the English language question, and we all know what SQL or Spark QL looks like. Oh yeah, that's correct, right? So we were doing that in our brain. So if this were a real application, I would write an eval test that had 10 of these things that I would put into a system prompt and say, if the question is how many houses were sold in Birmingham, this is the correct Spark QL for it. If the question is, show me the top 10 houses sold, this is what the answer should be. So I would put all that in as part of the system prompt, and then I would use an eval test that uses that pre-canned example data, and then I would write more tests against it, right? Basically, I would use the LLM to test what the LLM output.
Make it more robust.
And make it more robust, right? And the great thing about doing that, maybe great thing is not the right word, but one of the reasons why you would do that is because if you change the LLM, the large language model that you use as the basis for the application, from, let's say, ChatGPT to Gemini, or a GPT-5 to GPT-6, you could just run all these tests and see if it's actually working, right? So you basically, it's just like regular integration or unit testing. Yes.
So I was, for example, completely out of the blue,
Yeah.
use the Gherkin syntax to create myself a feature file.
Mm-hmm.
Then the description of the expected behavior outputs, created a specification by example table.
Yeah.
And said, okay, GPT-5 or, whatever. Claude's gonna take and put some output. You run it against this and tell me whether or not they got it right.
Yeah.
That's cool.
Yeah, 100%. You could write an eval test.
I hate that.
Yeah, it's only,
I'd like to have a job in 5 years.
yeah, you know what? You'll still, you'll be a AI slop fixer, a code janitor, right? So, or vibe code fixing specialist. How's that? So, all right. But here's the thing, there's, and I'm gonna stop the recording now, because we're just, that we can freestyle a little bit.